So now we are going to see gradient descent. First, the objective function. Consider the data set xi, set of all xi, yi. I varies from 1 to n. Let theta be the model parameter. Empirical risk, that is the cost function, is j of theta equal to 1 by n into sigma I equal to 1 to n Li of theta. Here Li of theta is the loss for the ith sample. Now gradient descent update rule, that is this is the general derivation. Here eta is the learning rate. Delta j of theta is the gradient cost function. Well, we expanding the gradient, we get the gradient function is equal to 1 by n into sigma I equal to 1 to n delta of Li of theta. Then batch gradient descent. It uses all training samples for each update and one update per iteration. The properties of BGD is converges smoothly to minimum and the computational cost per iteration is order of n. Next, the stochastic gradient descent. These are the different types of gradient descent. So instead of full sum in the BGD, approximate using a single sample. So delta j of theta approximately equal to delta Li of theta. It updates parameters for each sample, introduces randomness, also faster updates, order of 1 per step, noisy convergence. Then mini batch gradient descent, approximate gradient using batch B of size m. So this is the update rule. It combines advantages of BGD and SGD, efficient computation using matrix operations, computational cost is order of m, stable and faster convergence. So for convergence analysis, BGD is, that is exact implies smooth convergence. So then mini batch gradient descent. So uses entire training data set to compute gradient in each iteration. These are the advantages and disadvantages. In SGD, it is very fast updates, work well for large data set, can escape local minima due to randomness, suitable for online or streaming data. But noisy updates are there, that is high variance, fluctuates around minimum, may not converge exactly. Then mini batch gradient uses a small batch of samples, faster than batch GD, more stable than SGD, efficient with vectorization, that is GPU or parallel processing, most commonly used in practice. These are the disadvantages. Needs tuning of the batch size, still has some noise in updates. These are the comparison table. According to these features, the batch GD and SGD and mini batch GD are having the properties like this. Thank you.